cycle. It does not depend on light, but photosynthesis is occurs without light, so it's not dependent on light. What it needs is carbon dioxide. So we'll start with RUBP, which is just a sugar, and it's got 5 carbons and 2 phosphates attached to it. Carbon dioxide diffuses through the cell cytoplasm, so remember the cell, the cytoplasm is where all the organelles are located. Carbon dioxide diffuses into the cell. The carbon from this carbon dioxide attaches to this RUBP 5-carbon sugar. So if we add another carbon here, then we're stuck with a 6-carbon sugar with 2 phosphates. Yes?
Does that change it though? Like
It does.
what RUBP?
Whenever, yes, because this is RUBP, and then we added a carbon to it, it becomes very unstable, and it breaks apart, and it becomes 2 molecules of what's called PGA. PGA is just another carbon, it's a 3-carbon sugar, so another sugar, and they each have a phosphate attached to it.
What happens to the oxygen?
It's not necessary for this part. So we have the RUBP, which is the 5-carbon sugar. CO2 came in, the carbon attached to it became very unstable. It then broke apart and formed 2 molecules of PGA, another 3-carbon sugar. So another sugar just with 3 carbons. And phosphate attached on each end. This sugar here becomes energized because ATP and NADPH were sent here to this cycle. So we made NADPH and ATP over there. It's then sent here to this cycle. 2 ATP, so we have, remember ATP, it was like this. How do we get energy from it? Breaking the bond will release energy. And if we have 2 of those, and we took 2 phosphates off, right? Energy was released, it was given to PGA. We're left with 2 ADPs. These ADPs are then sent back to this cycle to be recharged. Same with the phosphates that just broke off.
So they're recharged because they added. And that's
These
how
phosphates are sent back over here to connect back with ADP again.
So Ms. Lowin, are the ATPs sent over here? Or
Yes, ATPs were sent over here. They gave their energy, because remember they hold energy, to PGA, and then what was left of them, the ADP and the phosphates, are sent back over here to be recharged.
So what does PGA do with that new energy?
Just a second. Also, NADPH, which holds energy, it also energizes PGA by releasing the electrons and the hydrogen ions. Because remember, that was the energy over here. It picked up electrons and hydrogen. It releases those and gives those to PGA as well. So then it turns into NADP. NADP is sent over here waiting for electrons and hydrogen. Okay? Energizing PGA turns it into PGAL. PGAL is what's necessary to make glucose. So we've got RUBP, the sugar. Carbon dioxide came in, the carbon attached. It became very unstable. It broke apart into 2 molecules of PGA. PGA was energized and became PGAL. PGAL, some of it is used to make glucose, an end result of photosynthesis. And some of it ends up right here, where there's an ATP molecule. This ATP molecule gives its energy to the PGAL, and it makes it RUBP again.
Can we go back to step 4?
Yes. 4. PGA was energized
And it was energized in the...
by ATP and NADPH.
After they energize it, do they go back to?
These things go back to the light cycle.
Okay.
Do they? And this.
And so then do they get, like, with the ATP synthesized, do they get more energy and then come back?
Correct.
What happens after they come back?
When they come back, this is a cycle, remember? It just keeps happening over and over. They release energy, they go back to be energized. Release, go back.
So when NADPH, does it like go back into NADP
Yes,
and has to be redone into NADP?
yes. So then, step 4, the PGA became energized and turned into PGAL.
So what they
Well, what's PGA like?
It's used
What's
to make
added to
glucose.
Just
Energy.
energy is added to it? That's
so is what they've released is that what makes PGAL?
The energy, yes. Turns the PGA to PGAL. PGAL is used to make glucose, some of it is, which is an end result of photosynthesis. But some of it is just changed back into RUBP. So some PGAL turns to RUBP to continue this cycle. And it does that by adding energy to PGAL.
Where
it
does
ever run
the
out?
glucose go,
No.
like, after it's made?
The glucose goes for plant energy, yes.
So PGAL uses some of its energy to make glucose, and then it's given more energy.
Some of it is sent out of the chloroplast. Some of it continues on this cycle and turns back into RUBP. Because adding energy from ATP here will turn it into RUBP.
So is the energy that's released, is that used to make glucose? Or is that a total?
No, glucose actually isn't occurring at this stage. The PGAL is just used to make glucose. So we haven't actually made the glucose yet.
So some energy is released, some energy is used for to make glucose, and then
Well, the
some energy
PGAL is a sugar. So it's used to make glucose. Some of it is turned into RUBP.
Why does the PGAL come before it's used to make glucose then?
Why does it come before?
Like at the bottom?
Right here?
Yeah.
Well, the PGA was made into PGAL. It's not necessarily coming before, so I could draw it like this. Some of it goes out right here
What's
And
its
some of it-
purpose if it goes out?
to make glucose.
Glucose? Oh.
Okay, so quick overview over here. Here you guys understood what was happening. We had sunlight and water coming in, going through the electron transport chains. An end result of this is hydrogen's pumped out here, oxygen is released into the cell or the atmosphere, ATP and NADPH are created from this first stage. Then we entered the Calvin cycle, stage 2. We added CO2, we created PGAL, which eventually turned to glucose, and NADP, ADP, and phosphates were sent back over here to be recharged.
So basically,
worked.
No, they are.
Oh, that's that step.
It used the ATP energy and the NADPH. When it used that energy, we're left with some phosphates, because they broke off right here. We're left with ADP, these two, and we're left with NADP because we used up the electrons and the hydrogen ions that were making it NADPH.
so the cycle already has NADPH and ATP.
Well, we made it right here.
Or I mean NADP is ADP plus,
They're created here because they gave up energy.
and then that's given over there, and then that cycle gives the other cycle ADP and
Right.
NADP. Okay.
Yes. And also right here, ADP is created when we're converting some PGAL to RUBP. So it takes some energy here, some more ADP.
So just NADP is created here?
ADP.
ADP?
so if the ADP and the ATP isn't used, it's sent back to here, right? Is that what you said?
It'll be used.
Like sent back?
Well, the ADP, anything that's uncharged, so ADP, phosphates, NADP, those are all sent back over there to get charged, to hold energy again.
So if it doesn't get
This
used,
cycle
it
needs
just
a lot of
gets
energy.
reused to be used?
All of the
Recycle.
energy will be used here,
Mhm.
and then what's left goes back over here to pick up energy.
Is there not like,
Question, so ATP doesn't have the extra phosphate that ADP does, so how does it get the phosphate from?
ATP does have 3 phosphates,
Oh.
but
I
the
saw.
bonds break to give the energy to the PGA. So when the bonds break,
It goes back into ADP.
there's two phosphates that are free floating here. They're sent back over here.